Okay, guys, this is it. The last set of notes for Chapter 7. This is on equivalent expressions, and this one is chock full of vocabulary. So just like in a core class, if you had to learn some vocabulary, you would make flashcards, so you could do the same thing with this. So we're going to kind of revisit the distributive property, and then we're going to revisit factoring, and then we're going to talk about a bunch of vocabulary. What are all the pieces in a problem called? So let's start with the distributive property. The distributive property. Hopefully you guys were not too intimidated by it and were able to get through the work. But remember, always making sure that your answers are correct is important so that you know if you're getting it or not. So the distributive property, it uses, and this is the guy that's always part of distributive property, multiplication. Put a box around that word. Sorry, creepy people in my room. To remove parentheses. To remove parentheses, and that's the big deal. So multiplication is like it melts away those parentheses, but you have to make sure that you multiply everything inside the parentheses by the guy outside. So then we talked about factoring, which is part of the distributive property, and so we just kind of call it the opposite of the distributive property. Okay, so what's interesting about this guy is it uses division. To put parentheses back into an expression. And you know me, I like the factor ladder, so that's exactly what I used. Okay, so I'm going to show you a separate way of doing it today, right now, real quickie. 27x plus 36. Let's say I wanted you to factor this, and you say, oh yeah, man, I know. 9 can go into both of those guys, so you can divide both of those numbers by 9, so that's going to go out in front. And then what you're going to get left behind in the parentheses is what you get when you divide by the 9. So again, we got 27x divided by 9. That's going to give me 3x. And then plus, and then 36 divided by 9 is 4. So remember, the GCF, greatest common factor, is 9. Okay, so that's another way that you can solve these problems. I love the factor ladder though. All right, so let's get into some new words. And the first one is the word terms. Or no, let's just call it term. What is a term? So it is a number, so one number, a variable, or a product of numbers and variables. Okay, so what is a visual cue that you have variables? Well, in expressions, so those are like mathematical phrases, terms are separated by addition so that's a good thing to know, or subtraction symbols. Looks like I'm yelling at you a lot in these notes, all these capital letters. Okay, so if you have multiple terms, or multiple, let's just call them items in an expression, terms are the guys that are separated, the values that are separated by pluses and minuses, okay? So for example, let's say we have 3x plus 4 plus 2y, we would say 3x, 4, and 2y are terms. Okay, so you're going to hear me use those words. Now, we've got a special name for a term that is a number only, like in our past example, the number 4, and that's called a constant. Constant, so it's a term with no variable. It's number only. Okay, so the best word for 4 is a constant. So the reason why it's constant is 4 is always 4. Whereas x could be anything we want it to be. So that's why it's a variable, because it varies. Yeah. All right, let's see what else we got. Okay, I think I have room enough for one more vocab word. This is a lot of big words. Another word that starts with C, coefficient. Coefficient. So in the product of a number and a variable, so in the product of a number and a variable, the number is called a coefficient. So I'm going to give you an example of that. So I'm going to highlight the colors. Let's make it this way. 6a squared in negative 5ab, so that's negative 5 times a times b, and 3x I'm going to say that 6, negative 5, and 3, those are the coefficients. So they are being the number part of a product that contains a variable. So they're not a number alone. If they were a number alone, they'd be a constant. But because they're part of a term that contains a variable, they're called coefficients. A lot of stuff that we do with those coefficients. So I'm going to go to my next screen. And you probably heard me talk about this today in our Zoom meetings. And that's the term like terms. So terms are part of an expression, what makes them like. So it's two or more terms that have the same variable with the same exponent. Same exponent. So we got same on this one. So let me give you some examples. So 3x and 5x would be considered like terms because they have the same variable. Working on the wrong thing here, sorry. They both have an x. The 3 and 5 are coefficients and they both have the x. Okay, so they're called like terms. 15y and 8y. They're like terms because they both have the variable y. The 15 and the 8 are coefficients. So here comes the reason why I bring this all up. Because we can do something called combining like terms. Now this is actually related to the distributive property. I'm debating whether to show you because it's kind of heady stuff. Maybe I'll show you anyway. So to combine, and you know what combine means. It means to put together, right? So if you combine ingredients, you make a dough, right? Well, depending on what you're making, right? So combine like terms. So this is a phrase you need to understand. It's an action. So we're going to do some math with this one. You're going to add or subtract. Depends on the sign. Oops, I don't know where I put that dot. Here comes our old friend we just talked about. Coefficients of the like terms. Okay, so the variables are going to be, they're not going to change, okay? So I'm going to write that. And I'm going to show you how this is related to the distributive property in just a minute. Variables never change. Okay? So I did talk about terms that look like terms, the 3x and 5x, and then the 15y and the 8y. But what I didn't do was show you some examples of unlike terms. Let me change my color here. Examples of unlike terms. If you have unlike terms, then you can't combine them. Okay, it's only like terms you can combine. So what's a little tricky is sometimes these look like they would, be like terms. So we have 28z and 13y. So why aren't these not like, why are they not like terms? Well, because one has a z and the other has a y. So, all right, let's try another grouping. How about 3a squared and 9a? Now, here's the problem. You might say, well, wait a second, they both have an a, but remember what the definition said? They have the same variable with the same exponent. So even though the a's match, it doesn't matter because one has an exponent of 2 and the other one doesn't have an exponent. So that doesn't work. All right, let's look at one more. 7a squared and 12a. a squared b. Now, at first you might say, wait, whoa, 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 whoa. These guys have the same a squared. That's right, but guess what? Second guy has also a b. So that's what takes it away from being like terms. Okay, so let me show you how we combine like terms. Now, the directions are not going to tell you to combine like terms. The directions are going to say, simplify each expression. Now, this is kind of a chicken way of saying, do anything mathematically that you can do. Okay, so it's not giving you any specifics. It doesn't say combine like terms. It doesn't say substitute in numbers and then solve. It doesn't say distribute. It just says simplify. So you're going to do whatever you can figure out to do that we've talked about. Okay. So simplify each expression. So we've got 3x squared plus 5x squared. So first thing we're going to look for is, do we have the same variable? So let's see, we have an x with a squared, we have an x with a squared. Chink, that's good. So look what I'm going to do. I'm going to factor out not the coefficient. I'm going to factor out the x squared. What does that leave me with? Well, 3x squared divided by x squared is just 3, and then the sign says plus, and then we have 5x squared divided by x squared is just 5. So we're going to go ahead and combine these together, and he's called the coefficient, and we're going to put the variable at the end because that's where the variable always goes. And that's your answer, would be 8x squared. Notice that the variable didn't change, right? Just we combined the coefficients. So that's one way to show you the problem. I'm going to show you a different way. Ooh, this is a good problem because there's like a hidden number. 5c minus c. Okay, so I think all of us would agree they have a c in common. Okay, now, both of the values have coefficients. And you're going to say, nay, nay, Miss Rosner, I only see a 5 in front of the c. I see nothing in front of the plain old c. Yeah, right. Guess what? It's there. If you can't see it, it's a 1. Okay? So, I'm going to show you a different way of doing this. So I'm going to take that c that they both have, and I'm going to bring it outside. So what I'm really going to do is I'm really going to divide both of those terms by c. So the c's cancel, and that's going to leave you with a 5. I think I need a little bit more color. And then 1c divided by c is going to give me a 1. Now this says subtract, so we're going to go ahead and do that. So we get 5 take away 1 is 4, and then we have a c. Okay, and that's the answer. So notice I did my factoring a different way, but again, and remember, variables always go at the end, so that's why I put mine in the back. Okay, let's do one more like that. And we get 9w minus 3w. So the first thing we do is we check if the variables are the same, and this one is. So I'm going to show you that strategy again. We're going to put the w in the back. And then we're going to take the coefficients. That's the numbers in front of the variables. So we have a 9, and then it says subtract, and then we have a 3. And we do that math. 9 take away 3 is 6. And then it gets multiplied by the w. So it becomes 6w. Pretty nifty, huh? Okay, so I think I'm going to go to my next screen. And we're going to do a crazy problem. So again, the directions are going to say simplify. And we're getting close to being done, but I'm going to show you the craziest problem ever. Are you ready for this? Okay, this should be number 4. 5a plus 2 plus 3a plus 4b plus a plus 12 plus 6b, are you getting excited? Plus 1, I know min is, plus a. Okay, so how do we deal with this? Number 1. Separate terms. Okay, so how you're going to separate is you're going to separate everything that is from a, has a plus sign. The things that are on either side of it, those are your terms. So that's the first thing you're going to do. Then you're going to rearrange them using the commutative property, that's changing order, and we're going to group the like terms. Okay, and then you're going to simplify each group. So I'm going to give you some ideas. The variables are in alphabetical order. I call it alpha order. And then the constant is at the end. And that's the format that we use. So we don't get to mess with the format. Format is something that everybody expects to see. So I'm going to color code my terms. So I have a 5a, I have a 3a, I have an a, and I have an a. So I got to remember that that means 1a and that means 1a. Okay, next, let's see, I'm going to go with constants. So we have a 2, we have a 12, and we have a 1. And then last, let's do this color, and we've got B's, 4B, and a 6B. Okay, so alpha order means we're going to group the A's together. So I'm going to put 5A plus 3A plus 1A plus 1A. Boom, boom, and put them all together. And then we're going to add to it the next group, and we're going to go with the B's. So I see a 4B and a 6B. Okay, and then we're going to group together the constants. So let's see, I see a 2, oops, plus a 12 plus a 1. Okay, so remember what we're going to do. We're only going to do the math with the coefficients. So we're going to do 5 plus 3 plus 1 plus 1, and the A is going to be in the back. Okay, and then we're going to do the math with the 4 and the 6. Oops, I'm going to do that a different color, sorry. The 4 and the 6, and then the B is going to go in back. And then I can actually do the math that's in the back here. So we have 12, 2 plus 12 is 14, and 14 plus 1 is 15. So I'm just going to say 15. Okay, so let's finish this problem up. We've got 5 plus 3 is 8 plus 1 plus 1, 9, 10. So we get 10A. Sorry if you hear any noise, it's my kitty cat. She's decided to visit. And then 4 plus 6 is 10, and that goes with B. And we already know that in the back is going to be the 15. And that's the answer. Is that crazy or not? Do you feel like it's super genius right now? Okay. Okay, 2 more examples. Let's see, we make them a little bit nicer than that one. 14y plus x plus 22y. Okay, so now that you've seen how I work that, I'm going to go ahead and use the commutative properties. I'm going to write that over to the side, just an abbreviation of it. Commutative. And that means I'm going to change the order. So the directions say that I need to have variables in alphabetical order, so I'm going to make the x go in front and then the 14y plus 22y, so the like terms are going to be in the back. Now I got three terms, so now I'm going to use the associative property, so I'm going to abbreviate that, because I need to put in some grouping symbols. So what am I going to combine? And I'm going to combine the 14y and the 22y. Okay? So poor little x just stays by himself. Okay? Now, here comes the weird thing. The next property I'm going to use is the distributive property. Because remember, we talked about the distributive property can multiply to get rid of parentheses. We can factor to pull out the GCF and put the parentheses back in. And we can also combine like terms. It all means the same thing, right? Because we're going to go ahead and take the 14 plus the 22, the coefficients, and the variable is going to get factored out because that's what they had that was the same. So my answer is x plus 14 plus 22 is going to give me 36y. Okay, now I can already hear, do we have to write the properties? No, you don't. Okay, I'm just pointing out how those properties play a role in what we do. So let's try one more. 36 plus 9y plus 5x. So again, first thing I'm going to do is the commutative property. Why? Because I want to get like terms next to each other. So that's going to give me 3x and alpha order as well, right? And we're going to want the 5x to be next to him. Okay. Then we're going to do the associative property. Why? Because we want to put parentheses around what we can do math with. So we have the 3x plus 5x plus 9y. Boom, boom. Okay. Then we get to do the distributive property. That's what happens when we are going to combine like terms. We actually are going to factor out the coefficients. So we're going to have 3 plus 5, and then x is going to be in the back. Now, poor 9y had no friends, so he's just hanging out. So do the math, and we get 8x plus 9y. And there you go. This is how properties help us solve problems as complicated as what we just did. All right, good luck, guys. We'll talk about it together in class. Bye now.